Okay. Can someone recap which question we were in the homework set 5? We were doing question 7, I guess. If I recall, question 7, question 8, have we done this? Like 10 is John and Peter. Sharma, can you recall? Can you recap?
No, sir, we haven't done it.
We have not done this. Okay. We have not discussed 8, but we have discussed 7, correct?
I think so. Yeah.
Okay. But before we get started, any doubts or basic questions? I know, Sharma, you had like a few doubts. Okay, so 2 things, right? If it's something specific, then definitely ask. If something more general, some concept, then also we can go over some like general rough edges or something. Anything that's bothering you, Sharma? Or anyone for that matter, from the permutation combination?
I've just done the homework 6. I haven't done the homework 5.
Okay, homework 5 is the one which we were discussing, right? Those 15 questions. Right now we are on question 8. Okay, all right, that's fine. Follow along as best as you can and then go back and do the homework 5, the remaining questions also. Okay, so anyone else with any questions? Kunsh, Vihan, Ananya, Antia, okay. Recording is happening, right? I want to make sure. Yeah, okay. Okay, this one, question 8, Kunsh. How did you approach? What did you get on this? Peter wins his service with P and John wins with Q. Yeah.
So I thought we were just gonna go straight to 6. So I didn't.
Why would you think that? We didn't finish this paper, right? Okay, all right. I got my answer. You have not done this. Okay, but even if you go to paper 6, you should have done this, right? Homework 5 was even before that, right? Should have finished this, right? Okay, all right. Vihan, were you able to do this?
No, so I got stuck on this. I didn't understand how to solve this question. Actually.
Okay. I don't buy that excuse, Vihan. I mean, it's not an overly complicated question or nothing too much to understand per se. Anyway, we'll discuss anyway. Ananya, from you, anything?
So, because P is greater than Q.
Yeah.
And P plus Q is greater than 1. So, P is greater than half. So I think it'll be
A. Okay, P is greater than half. Intuitively, you think it's A. Okay, fine.
Yeah.
So basically, she's saying P plus Q is greater than 1, and collectively they are adding up to more than. P plus Q is greater than 1, and P itself is greater than Q. Therefore, P has to be greater than half. Q may or may not be greater than half. Q might be less than half. Very likely, Q is also greater than half, right? Typically, when you're serving, you have a higher chance of winning, right? From even if you're a weak player, during your serve game, you have a higher chance of winning. Anyway, let's not make any such assumption, but that's okay. Now let's do whether let's work it out and see whether intuition gives a consistent answer or not. Okay, so the first case, so what's happening? Peter is serving, right? So I'll just put service by Peter, and then this is John, and then by Peter again, right? So Peter serves first. So this is serves. Okay, and then we'll from Peter's perspective, he has to win at least 2 consecutive games, which means he must win here, and lose here, or win here, and lose here, or he must win all 3. Okay, so we are okay. Kunsh, you're in agreement with this 3 outcomes here? Either all 3 wins or 2 consecutive wins in this. Okay, now let's put probabilities for each of them, right? For Peter, when he's serving, his probability of winning is P, right? And this is for John. For John, it's Q, and for Peter, it's P, right? So P, Q, and P, right? Now, maybe should I just replace instead of Q, I'll just call it J, so that I don't have to think too much, right? So I'll just replace whatever is Q in this question, I'll read it as J. So Q is John, really, right? Okay. Sharma, you're with me, right, so far, with the notation and all that? Okay. Now, for Peter to win the first game, the probability is, because he's serving. And for Peter to win the second one, it's 1 minus J. Because remember, John is serving, but Peter wants to win. So it's 1 minus J for Peter to win. So from Peter's perspective, from Peter's wins, right? And then Peter wants to lose this, or rather not wants to lose this, but he ends up losing this in his own serve, which is 1 minus P. Okay, we agree with all these probabilities. Ananya, you're in agreement as well with the probabilities here assigned. Okay, now similar, very symmetric here. So this is 1 minus P, this is 1 minus J, and this is Peter is winning his own serve, which is P. And now Peter is winning his own serve, Peter is winning his own serve, and then he's winning John's serve, which is 1 minus J. So the total probability for case A, so this is case A. Case A. Okay, so case A would be the sum of all three probabilities. So what's common from all the three terms? I can extract what's common. So P is common. So P is common here. And then 1 minus J is also common. 1 minus J is also common. Okay, so let me take P and 1 minus J common outside of all the three terms. So from the first term, I get an extra 1 minus P. From the second term also, I get an extra 1 minus P. From the third term, I get a P. Okay, so finally, this simplifies to P into 1 minus J into, how much is this? 2 minus P. Okay. All right, now let's do the case B scenario. So in case B, okay, so again, same thing, Peter, John, and then Peter. So probability of him winning, sorry, this is John, Peter, right? John is serving first. Right? So John is serving first in this case, Peter next, and then back to John. Okay, and the same probabilities will be J here, small p here, and small j here. And now Peter's wins again, Peter's wins. So those will be same, right? He still wants a win, win, and a loss, or a win in the second and third game, or straight wins all through. Now let's assign probabilities for each of them. Sharma, what is the value? What should I put under this W? The first W.
J
No,
for Peter, then P.
no, but remember, J is serving, right? John is serving, but Peter wants to win this. That's what the W indicates.
1 minus
1 minus J, exactly, right? Again, we are thinking in terms of Peter's perspective. Peter wants to win, but it's John's serve. John has a J probability of winning in his own serve. Therefore, this is 1 minus J. Okay, Sharma, can you complete the first row fully? For the next one, what will it be?
For Peter serving, it'll be P.
And for the last one, it will be?
1 minus P.
No, it's John serving.
Oh, John is serving and Peter. Also, then John wins.
Therefore, what should I put?
1 minus J. Or
No,
just
just J, no, because John has to win this. Agreed? Yeah, you're in agreement now? Yeah, John has to win this, right? So from Peter's perspective, it's a loss. It's John's serve, so it's J. Okay, and this line is exactly symmetric, it's just, except that it's reverse, right? So this is J, and Peter is winning his own serve. And this is, the last one is John's serve, by Peter is winning. Okay. Kunsh, can you complete the last line? So what number should I put below the WWW?
It's 1 minus J for the first one.
Exactly.
Then it's P, and then it's 1 minus J.
Perfect. Yes. Okay. So all of us are in agreement with this. Now, again, let's extract what's common. So P is common between all the three terms, and 1 minus J is also common between all the three terms. So I can extract the sum of all of them is P into 1 minus J into what's coming in the first one. J is coming in the first one extra. J is coming in the second one extra. And in the last term, it's 1 minus J. Okay. So finally, this simplifies to P into 1 minus J into 1 plus J. Okay. So now our comparison is between this expression and this expression. So we are comparing whether this is equal or this is greater. We are comparing between these two, right? We don't know which is bigger, right? We observe that P into 1 minus J is common for both of them. So that's not going to be the differentiator. The differentiator is going to be the balance. 2 minus P on one hand versus 1 plus J on the other hand. So let's compare 2 minus P versus 1 plus J. Okay, so I can put the P and J to one side. So effectively, it's a comparison between 2 minus 1, which is 1, versus P plus J. Right? I've just moved. I don't know what inequality or equality to put. I'm just saying versus right now, right? But we know P plus J is given in the problem to be greater than 1. 1 is smaller than P plus J, right? Therefore, scenario B is actually a better chance, even though it's counterintuitive, Ananya. So yeah, you might be thinking that Peter has a better chance when he starts to serve first, but it's actually he has a better chance when John starts first, if his goal is to win 2 consecutive games. Of course, if the problem statement changes, it will change. But for his specific goal of winning 2 consecutive games, it's the latter. It's part B, which is favorable. Okay. So why is it? So roughly, let's put some numbers to it, right? So let's say P is, P is a strong player, right? P is greater than J, right? So let's put some numbers. Let's say P is, I'm just giving some random number, 0.8, right? When he serves, he has a 0.8 chance of winning. Whereas J is also a decent player. When he serves, he has a 0.6 chance of winning. Okay, generally when someone serves, he has an advantage, right? That's okay. So which means 1 minus P is how much? 1 minus P is 0.2. Okay, and 1 minus J is 0.4. So let's understand the numerical of this, right? Right. So, so what is 2 minus P? So 2 minus P, the differentiate. 2 minus P is 2 minus 1.8, which is 1.2. So this is 1.2 in our example. And 1 plus J, so this I'm comparing this versus this, right? So 2, I'll put it up here. So 2 minus P in our numerical example was 1.2. Okay, so 1.2. And in our numerical example again, 1 plus J was 1.6. Okay, so that's because, so if Peter serves first, then almost certainly he's going to win these 2 because he's a strong player, plus he gets to serve first, right? But this one is John's serve. So John has an advantage of winning, right? As a real point, he has an advantage of winning. And if John wins, he'll disrupt Peter's chance of winning. Peter's chance of getting 2 consecutive wins, even though Peter will hands down, maybe he wins 40 love here and 40 love here. All of you know tennis scores, right? Let's say he wins 40 love here, 40 love here, right? But if John wins this, let's say 30-40 or something in John's favor, then Peter is losing the opportunity of winning 2 consecutive games. On the other hand, if John serves first, Peter has taken the center spot. This he'll surely win, almost surely win, because he's a strong player, plus he's serving first. Now, between these 2, he can manage to win one of them. Then also he's good, right? So he has a better chance that way. In the B scenario, he has the first game and third game are not exactly to his advantage, but with some probability he can win at least one of them, let's say, right? Maybe this one he'll lose 30-40, but maybe he'll win this one like 40-30, right? There's a decent chance because he's still a stronger player than John. Does it make sense? Which is why it's little counterintuitive. In B, he has a higher chance. Does this explanation make sense, Ananya? Yeah. And to be fair, I too thought before solving the problem that it is an obvious dumb question, that part A, scenario A will be hands down the obvious this thing, right? But when you read it again, it's actually 2 consecutive games. It's not any 2 games. It's 2 consecutive games, right? Does it make sense? All of you okay on this? Sharma, you're okay with the intuition for why part B has a better chance? Okay, cool. Yeah, so who else joined? Anahat, you joined. Okay, cool. Problem 9. Okay, I'll be given a few different variants of this question as we discuss. Okay. It looks like many of you have not even done this paper, right? At least Vihan hasn't done, Kunsh hasn't done. Anahat, did you do this? Yeah, go ahead.
Is the probability just 50%? So
For question 9, is it?
Yeah, because I
Okay.
found my answers for some of the questions.
Okay, so see, there is some asymmetry. There are 5 odd numbers, 1, 3, 5, 7, 9, whereas there are only 4 even numbers, 2, 4, 6, 8. So I determine the probability both numbers were odd. It's unlikely to be 50%.
Oh,
Right,
I
because
forgot. So I misread the question. I forgot.
If the question had been 0 to 9, then without even dropping my eyelid, I would say it's half by symmetry. But when symmetry is not there, it may be still half for some other reason, but it's not obviously half. right? Okay, can we all work it out since many of you have not done it? Other than, I think, Ananya, Tantia,
Yes, I have done it.
you have done this as well? Okay. All right, hold off your answer 1 second, Anahat, and Ananya as well. And then let's give 1 or 2 minutes for people to solve, and then we'll discuss. I'm not going to do that with every question in this homework. I really should have done this, but at least for this one, I'll give people some chance.
I'm getting 4 divided by 9.
4 by 9, okay?
Yeah.
For the probability that both were odd.
Yeah.
Okay, all right. Let's discuss, guys, to be fair to the people who have done it, and I don't want to waste class time on something that was supposed to be done. Okay, all right.
So I got 5 by 8.
5 by 8.
Yes, sir.
5 by 8. Okay, all right. Anahat, what did you get?
5 by 18.
5 by 18. Okay, 5 by 8, 5 by 18, 4 by 9. Anahat, I doubt 5 by 18 because the answers are expected to be close to half, idhar udhar. And also I doubt 4 by 9 because there are more odd numbers, right? So if at all anything, it's likely to be more than half. Whoever called 4 by 9, who was that? Called 4 by 9? Vihan, was that you?
Yeah.
Okay. Do you agree it's more likely to be more than half because there are more odd numbers? Anyway, let's do, right? So when 2 dice are thrown, what are the outcomes possible? Odd, odd. Okay. Odd, even odd, or even. These are the 4 outcomes possible, correct? Right? So what is the probabilities for each of them? So there are 1, 3, 5, 7, 9, 5 odd numbers. 1, 3, 5, 7, 9, sorry. And then 2, 4, 6, 8. There are 4 odd numbers. Okay. So the probability of this is 5 by 9 into 4 by 8. You should get the first one which is odd, which is 5 by 9. Ananya, Sharma, do you agree? 5 by 9 into 4 by 8 for getting an odd and odd. Odd and even, 5 by 9 into 4 by 8 again, right? There are 4 even numbers of the remaining 8 numbers. Here, first one should be even, which is 4 by 9. Second one must be odd, which is 5 by 8. And in this one, even and even. All right, even and even. So first one must be even. Second one must be even again. Am I right? 1, 3, 5, 7, 9. Okay, let's add and check everything adds up to 1. If it does, then we are okay. If it does not, then something wrong. So it's 20, 20, 20, and 12. 60 plus 12 is 72. So 72 by 72, I'm guaranteed that this is right. Okay, so in fact, let me put this also here so that it's aligned. So this is 5 by 9 into 4 by 8 as well. Okay, now the question says, what does the question say? It was observed that the sum was even. Okay, and determine the probability both were odd. So which means, what is the question saying? It's probability that both odd, which is odd, odd, given sum is even. The conditional probability, as we discussed last class. So given sum is even. So if it's odd, odd, the sum is even, right? So sum is even. So this event has happened, or this event has happened. So definitely these events have not happened. The sum is even, is given to be even. Therefore, the events that have happened are the ones which are ticked, right? So this has happened with a probability 20 by 72. This has happened with a probability 12 by 72. Okay. Now, we want the relative contribution of both being odd, as in we want 20 by 72 as a fraction of the sum of 20 by 72 and 12 by 72. The 72 can go anywhere, everywhere. So it's effectively 5 by 8, as Ananya got it right. Right? Does it make sense, all of you guys? Sharma, does it make sense? Relative contribution from the specific scenario among all the possible scenarios, right? I ruled out the scenarios which are not possible. That's how conditional probability is, right? If the problem was just, what is the probability that 2 numbers were odd, without giving the extra information that the sum was even, then you would say 12 by 72. That's relatively easier, right? You just have to not worry about the other outcomes. You want the first one to be odd. You want the second one to be odd. 4 by 9 into 3 by 8. But now you're given this extra information that the sum was even, which means you have to specifically decide which of the events happened. Among them, what contribution came from the specific 12 by 72. All of you okay in this? Anna, did you find your mistake?
No, so that's what I was about to ask you. So
Yeah.
the way I did it was I saw that any two odd numbers you add will have to be even anyway.
Correct.
So I just did 5 choose 2 over 9 choose 2. Why would that not be right?
Okay, so probability, right? So you mean 5 choose 2, 5 choose 2 for choosing any
I
two.
also did that way only.
5 choose 2 upon 9 choose 2. Yes, that's the
Yeah.
probability of getting 2 odd, which will be 20 by 72, right? 5 choose 2 by 5 into 4 by 2 upon 9 into 8 by 2, which is your 20 by 72, which is what I have it here. Which is what you called out your final answer to be. You called it as 5 by 18. You forgot the whole, given the sum was even concept, right? The sum was given to be even, right?
As in,
No.
I don't understand why that affects.
Okay. Two different questions. Okay. One question, I'll strike off this line. It
The
was
thing is,
observed.
if both of the numbers are odd, the sum will be even anyway, right?
True. If both of the numbers are even, then also the sum will be even. If one is odd, one is even, the sum will not be even, the sum will be odd. I agree with all of your statements. Now, imagine a situation, imagine a problem where I have striked off this line. It was observed that sum was even. If that line was striked off, your answer is right, 5 by 18 or 20 by 72.
Mm.
Okay. But now it's given the sum is even, which means, I'll erase this, which means the second and third did not happen. All right, these two did not have. It's only odd or even in contention right now. Therefore, the denominator is reduced now, and therefore you have a higher conditional probability. That's what the conditional probability is all about. You're with me or not with me still, Anahat?
Kind of, but no, what I'm asking is what I'm calculating here. Why do I have to remove the even? This is just for odd now. We don't consider even in this scenario.
No, we have to consider because it was observed that sum was even means what? You're ruling out the possibility that odd even or even odd has even happened.
Yeah.
Only even or odd has happened. It's the probability, therefore, is you've been given extra information, right? Therefore, your probability will be higher, right? You're forgetting this extra information. It was observed that the sum was even. Oh, bol rahe ho tum.
Okay.
No, you don't seem convinced. I won't proceed unless you're convinced.
It's fine. I'll try to figure it out.
No. Okay, what is the whole premise of conditional probability? Again, we went over another example last time, right? What is the probability it's raining in Mumbai for a prisoner who's in a dark cell who has no idea, right? What is the probability that it's raining? He'll say 3 over 12 because he knows June, July, August it rains. So he does not even have a sense of time because he's in the prison for ages now. He'll say 1 by 4. But to the same prisoner who is again in the deep cell, he has no connection with the outside atmosphere. You're saying today it's murky in Mumbai. What is the probability it's raining? He'll say it's 1 by 2, maybe a higher probability, right? The extra information will make him the probability higher, right?
Yeah.
The extra information here is that the sum is even, which means I'm ruling out the possibility that odd even or even odd has occurred. It's only odd or only even that would have been possible. Among them, what is the contribution due to odd?
Yes, that contribution is 20 by 72, right? That
20
will
by
be
72 out of what? 20 by 72 plus 12 by 72. The denominator is not sum of all four. The
Oh,
denominator is just...
okay. Yeah, now I get what it is.
Thank you. That's the expression I was waiting for. Okay. Not like, okay, fine. Okay. That's exactly what I was looking for. Yes. Good. Does it make sense? All of you? Sharma, you're also convinced completely? It should be intuitively convincing, not because I forcefully say this. If it's not, then there's no point. Anyone? I'm just taking her name, but I'm just saying, all of you with me, right? Completely with me, right?
So
Yes, Ananya.
by this, I did by another method.
Go ahead, please. What
So
did you do?
So I took possible combinations for
Yeah.
that odd numbers were picked, which is 5 choose 2, and possible combinations for even numbers, which is 4 choose 2, which is 6.
Yeah.
So can I do with that?
Absolutely, yeah. So you're essentially, you completely eliminated the denominator. You're saying there are 5 choose 2 ways of selecting 2 odds, which is 20 ways, 4 choose 2 ways of selecting 2 evens, which is 16 ways or 12 ways, whatever, right? Or is it, or maybe, sorry, 10 and 6, I guess, right? 10 and 6. And then you're saying 10 as a contribution out of 10 plus 6, same thing, which is the same 10 by 16 or 5 by 8. Yeah. Okay, all right. So that was question 9. Okay, question 10. Question 10 should be fairly straightforward. I'm not even in the mood to discuss this. Okay, the 2 boys. Sorry. Probability that these 2 guys sitting at the end of the row. Punch. What is the probability?
0.
The 2
I got in decimal form.
decimal or
0.1.
fraction doesn't matter. 0.1.
0.1.
You can also say 1 by 10, right? What do you mean you got it in decimal? Okay, fine. Fine, decimal is also fine. 1 by 10, right? It's not like a weird decimal where it'll take ages to convert to fraction. Yeah, 1 by 10, fairly easy, right? So basically 1, 2, 3, 4, 5, right? The total ways in which you can place them is 5 factorial. If you want j and k at the ends, you can either put jk or kj. So there's 2 ways or 2 factorial ways. And then remaining people can be arranged in 3 factorial ways. So this will simplify to the 3 factorial will cancel with the denominator, right? The 4 and 5 will be what will remain. So that'll be 1 by 10. Okay, all of you with me on this one? Vihan, you're okay? 1 by 10, right? On this one. Another way to do this same problem, another approach could be, see, the last 2 spots are, let's say, special spots. They're marked in red, right? Now, some 2 people, let's say that 5 friends are J, K, L, M, and N, right? Some 2 people have to sit at the far ends. Those are the special people, let's say, right? How can I choose 2 special people from 5? I can choose them in 5 choose 2 ways. So I have 10 ways in choosing a pair of special people who will get to sit at the ends. For it to be the JK combination, it's one of those 10. So it's 1 by 10. Does it make sense? Another way to look at the same problem. Okay, does it make sense, all of you? Okay, what is the probability that say they sit together? Okay. What did you get on this one, Ananya? If you've done this.
So I got 2 by 5.
2 by 5. Okay. Anahat, did you also get 2 by 5 if you have done this? For them to sit together. Anahat is away, looks like. Okay.
Sir?
Yes.
Wouldn't it, I would assume it'd be the same probability, no, sir?
For them to sit together?
Yeah.
Why?
Oh, wait, no, because they can also be in different. Oh, yeah, no, sir. Never mind. No.
By the
Yeah.
same symmetry argument, were you thinking? Or
No, I forgot that they can be in different positions.
they can,
across. Yeah. I
exactly.
forgot
They can
about
be
that
different
part.
positions. Okay. So
Yeah.
again, multiple ways to do this. Let's put J and K in a box and say they'll travel in a box. So effectively only 4 seats, right? So 1 seat is actually a double seat marked for J and K to sit together. So we have 4 factorial ways. Let's say the box happens to be here, but if you open the box, it's actually 2 seats there, right? And within the box, they can be sitting JK or KJ, this way or that way. So 2 factorial ways of them to sit within the box itself. And then total is 4 factorial. So 4 factorial cancels off with 5 factorial, leaving a 5. So it's 2 by 5 indeed. Okay, Sharma, is this clear to you? Why 2 by 5?
So but what is the formula exactly for these kind of sums?
Okay, there's only 2 things you have to remember, right? There's choosing, there's arranging. Okay, so let's go over that again, right? So in all of these permutation combination probability problems, there are only 2 exercises we are doing. One is choosing. What is choosing? That means ordering does not matter, right? So I have 10 objects. I have to literally choose 3, right? So that is your n factorial by r factorial, n minus r factorial, right? So you're aware of this one, right? So, or in other words, it's just 10 into 9 into 8 by 3 into 2 into 1. Okay, so where did I use a choosing example? For the same problem, you can approach in multiple ways, right? So the alternative way that I gave for part A, what did I say for part A again? Let's come back to part A before we go to part B. So for them to sit at the end of the row. So I said there are 5 people. Some 2 people have to anyway get the special seat, which is the left end and the right end. It could be any 2 people. Okay, it could be J and L, it could be M and N, it could be J and K. Like that, there are 10 combinations because 5 choose 2 happens to be 10. You're with me, Ananya, Sharma? Okay, now of these 10 pairs of people, the pair could be J and K with 1 by 10 probability, right? Because it's just one of the 10 pairs. Okay, therefore it's 1 by 10. That's one way to look at solving the first problem. The only other formula you need to know is arranging. And arranging is what? So let's say you have 4 seats and then 4 people. How many ways can they sit? You have to call A, B, C, D. You have to call someone to come and occupy the first seat, which is in one of the 4 ways. Someone should occupy the second. Someone else should occupy the third seat. And then the last seat, there's only one option left. Whoever is remaining has to occupy. So that's just R factorial. Depending on if there are people and R seats, they can only sit in R factorial. These are the only 2 things you need to know. And both of them are intuitively as well. It's obvious why you get this R factorial, and it's obvious how you get this as well, right? Anyway, I suggest you go and watch the last time's recording also once more, please. But are these 2 clear, Sharma? These are the only 2 things you need to know. And now for this problem, so it's how you apply each of them for a specific question, right? Now, what am I doing here? For J and K to sit together, what is the probability? That's the question, right? So what I'll say, the denominator is obvious. Denominator is 5 factorial. No restrictions at all. Anyone can sit anywhere. There'll be 5 factorial. That's clear. The denominator is clear. Now, the numerator is you're forcing J and K to sit next to each other. How are you going to make them sit next to each other? I will say, put only 4 seats, but one of them will be a special double seat, right? Where J and K will be sitting, right? So you can imagine a situation where there's only 4 seats because J and K are actually in a box, right? Now, you can assign L here. Let's say the combination of JK, they are in a box here, N here, and M here. This could be one of the 4 factorial arrangements. There are 4 factorial arrangements for this one. Do you agree? Okay. And now, within the box, you can open up and say J and K will be sitting left, right, or right, left. So there's 2 factorial ways of arranging them. And that's it. That's your answer. Does this help?
Yeah.
Okay, cool. Nice. That's question 10. Question 11. 8 people enter a room. How many handshakes will there be? Okay, Kunsh.
7 factorial handshakes.
7 factorial handshakes. Okay, explain why.
Because so the first person, he shakes hands with 7 different people.
Yeah. So A, B,
So
C, D,
that's-
E, F, G, H, let's say. E, F, G, H. Okay. First person
Yeah.
shakes hands with 7 people. Okay.
Right. Now imagine that's A. Now B shakes hands with everyone. So the 6 left except A, because you already shaken hands with A. So that's 6. And
Yeah.
then
But why are you multiplying? What is the logic in multiplying A? Okay, let's say A is shaking with.
So?
Yeah.
Yeah, I got 28.
Okay, 28. But first I want to discuss Kunsh's answer. Kunsh, I agree 7. Okay, but then why are you multiplying with 6? What is the logic for multiplying by 6? Multiplying happens when you're mixing and matching. Let's say I have 3 shirts and 5 pants and 2 ties. I can pick any shirt and any pant and any tie. That's when the mixing matching happens. Here you're saying A
Right.
shaking hand with C, getting multiplied with B shaking hand with F. Doesn't make logical sense, right? You have to instead add, no?
right. Yeah.
Right? So
Yes.
what you meant to do was 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, which will tally with what he's got also, and Ananya also has got, which we know is 7 into 8 by 2, right? N in 10 plus 1 by 2. Sum of numbers. Sharma, you know this, right? 1 plus 2 plus 3, so 1 till n is N in 10 plus 1 by 2, which is 28. Another way to do this is, any 2 people that you choose, you're going to have exactly 1 handshake. The number of ways in which you can pair up people is the number of handshakes, which is 8 choose 2. We are in the choosing game, right? 8 choose 2, which is also the 8 into 7 by 2, which is 28. Does it make sense? Do both approaches make sense? And Kunsh, more importantly, multiplication doesn't make sense here at all, right? It's addition,
Right. Yes, sir.
right? Okay. Now, one small twist to the problem. Let's say instead of 8 people, I will say, let's say there are, okay, fine. I'll say 6, okay, I'll say 5. Okay, so that it's okay. Or 7. Okay, 7 couples, which is 14 people. So 7 couples enter a room, right? And every person shakes hands with every other person except your spouse, right? Because it doesn't make sense, right? Just imagine they're coming together from home, they're going to come to the party and shake hands with themselves. Kya baat kar rahe ho, right? Obviously, they're not going to shake hands in the party with their own spouse, but they'll shake hands with everyone else, right? How many handshakes will there be in this case? All of you clear on the question, right? 7 couples enter a party room. Each person shake hands with every other person except your own spouse. How many handshakes?
So is it 84?
84. Okay, all right.
I think I'm wrong, but
Okay,
wait, I'll try it. I'll check it again, but
okay, fine. Anyone else agree or disagree with him? Sharma.
Yeah, even I got 84.
Okay, all right. Can you, Sharma, can you explain your 84?
Because there are 14 people.
Yeah.
And you cannot shake hands with your spouse or yourself. So it'll
Yeah.
be into 12. And divide by 2 because because you won't shake like there'll be 2.
Excellent, excellent, excellent. Yes, that's one way of thinking, right? Right. So basically what she's saying is each of these 14 people, right? If you count, like I'm A, right? So there are 6 other couples. There are 12 people with whom I'm going to shake. I'm not going to shake hands with myself. I'll look stupid. I'm not going to shake hands with my wife. I'll look stupid again, right? So it's only 12 people I'm shaking hands with. Same applies to each of the 14 people who were there in the party. Of course, I'm dividing by 2 because each handshake gets counted twice. Okay. Any other way, Ananya? Did he do in a different way to arrive at the same 84?
14 C's 2.
Exactly.
97.
Exactly. Yeah. So this is what I was thinking also, but her answer will exactly tally with this. What she's saying is exactly same as the previous problem. Just imagine for now there are 14 random people, then the answer will just be 14 choose 2. So that'll be 14 into 13 by 2, which is 91. But now the extra restriction that you're not shaking hands with your own spouse, there are 7 couples. So I'll subtract off those 7. It's good to see 2 approaches giving the same consistent answer. Are both approaches clear? Whoever is took the other approach, all of you in agreement with the other approach? Sharma, you understood her approach as well? Yeah, and vice versa as well. Okay, cool, nice. Question 12. Okay, how many 3-digit numbers can be formed using, just 1 second, okay. How many 3-digit numbers can be formed using the digits 0 to 9? Okay, bad question, because it doesn't say whether the digits can be repeated or they are not repeated. Okay, so let's approach both ways. Okay, so first let's say no repetition allowed. Okay, and then we'll repeat. We'll do the same question with repetition allowed. So no repetition allowed. Okay, how many 3-digit numbers can be formed using 3-digit numbers? So which means what? A number like 767 will not be allowed because 7 is being repeated. A number like 05 will also not be allowed because you cannot start with 0. So always I encourage you to write down some examples like this. That way you know what is allowed and what is not allowed. Whereas 609 is allowed. Okay. Vihan, how many numbers?
sorry.
What's the answer for part A?
So I'm just solving on.
Yeah. Or if someone has an answer, you can call out. Let's wait for 1 or 2 answers.
So I got 648.
648. Okay. Vihan got 648. Sorry, Kunsh.
Yeah.
Okay. Sharma, your answer matches or disagrees with him?
No, I'm still working on.
So will it be 900?
Yeah, what's the question? Sorry.
Will it be 900? I'm getting 900.
900. Okay, all right.
Yeah.
Okay, explain your 9. Okay,
Yeah, so basically, in the first place, as you rightly said, you can't have 0.
yeah,
So then you will have 9 options for the first place.
yeah.
In the second option, you can have 0. In the second place, you can have 0. So then there'll be 10 options.
Hmm.
And then, actually, no, wait, but then I can't multiply by 10 again because there would be repetition.
Exactly. What you answered was for repetition allowed.
Yeah.
In fact, that's the answer for the repetition allowed, right? And literally every 3-digit number from 100 to 999, which is the difference is 899. Therefore, the number of numbers is 900. There's 900 3-digit numbers, right? So with repetition allowed, there will be 900. That will be the answer.
Yeah.
Yes. And now, given you started, same thing. The logic is same. You cannot start with the 0.
Yeah.
As far as the second digit is concerned, it can be anything except the first digit. It could be 0.
First place, so 9
Right? So there
again.
are 9
right?
options. And the third one
And
is
then
8
eight.
options. It cannot be anything other than it can be anything other than the first 2. So it's 9
So
into 9 into
640.
8, which works out to 81 into 8, which is 648. Yeah. Makes sense? Sharma, does it make sense to you? 648? Okay. Can you take the next one, Sharma? How many of these numbers are divisible by 5? Or actually, all of you will do it, but let's see who calls out. Oh, sorry.
So to answer this, with repetition or without repetition?
We're still doing no repetition, and then we'll come back with repetition after that. Anath, I'm seeing your message only now. Is your mic better now or still okay? Still not okay?
Yeah, it's fine.
It's fine now, right? Okay. Okay, anyone who has an answer for divisible by 5, the second part.
126.
136, you said, Anahat? Okay, all right.
Yeah, I could have made some calculation error, but
Fine.
But I-
Okay. Sharma, you're saying
I'm not sure, but is it 162?
162. Okay. Any other answers?
So I'm getting 84.
84. Okay. Sharma, why don't you explain your 162?
Similar, because if it's divisible by 5, it has to end in either 0 or 5.
Okay.
So the first number cannot be 0, should be 9 into 9, since there's no repetition, into 2.
Okay.
The
One mistake you do. If the last digit was 5, so you're filling the last digit so that you're ensuring it's a.
Oh, so there's no Oh, so then would it be? Oh, yeah, I understand.
Then you have 2 cases. Yeah. So if the last digit is 5, I cannot use it for the first digit. If the last digit is 0, then I'm good, because the first digit. So in one stone, I have like 2 fruits, right? So I'm free for the. So therefore, you have to split into 2 cases. So let's split into 2 cases. We'll discuss the answers and see whether it tallies with 136 or 84 or something else. Okay. So the last digit, it's not symmetric. So we'll deal with one case where the last digit is 5, another case where the last digit is 0. If the last digit is 5, then which means, okay, this is the number itself, right? This is the number and this is the number of ways. Okay. The number of ways I'm putting at the top. Okay, there's only one way because you're literally putting 5 in the last digit. And then the first part can be anything other than 0 or 5, which means I have eight possibilities. And the second digit can be anything other than what is occupied in the first or the last digit. Therefore, there are 8 choices. So there are 64 ways for this case. On the other hand, if the last digit is 0, which means you have locked it with 0, literally one way, you have used up 0. The first digit can be anything other than 0, which includes 5 also, right? Therefore, you have 9 choices now. And 9 into 8 into 1 for the same reason, which is 72, which agrees with Anahat's answer. 136 indeed. Well done, Anahat. Does it make sense? Okay. Sharma, it makes sense to you as well. Whoever got 84, who was that? Can you explain your 84? I forget who that was. Was it Bihan?
Yeah,
Kunsh.
it was me, sir.
No,
Go ahead.
Yeah, I made some. I didn't take it as 2 separate things. I combined them as took it as one, which was my mistake.
Okay. Yeah. Yeah.
So
So
I also made the same mistake. I took it as the same thing together. That's why I got a
okay,
wrong.
understood. Cool. That was question 12. Question 13. Okay, 10 points are allocated, two-dimensional plane. No 3 points are collinear. Collinear we get, right? Collinear, same line. So no 3 points are in a straight line. How many line segments joining 2 points can be drawn? Right? Fairly easy, right? 10 choose 2, right? Because the 10 points are randomly here, here, here somewhere. With pick any two, I get a unique line segment. So it's 10 choose 2. Agreed? Sorry, I should have asked someone to call out. I just went with it, right? So 10 choose 2 is 45. All of us agree it's an easy question. Okay. What about B part? Sharma? Actually, not Sharma. Ananya, Tantia, what did you get for part B?
So I got 120, 10 choose 3.
10 choose 3, right? So same logic. A triangle is formed by picking any 3, and you're guaranteed they're not collinear. Therefore, it's 10 choose 3, which is 10 into 9 into 8 by 3 into 2 into 1. So it's 12 into 10, which is 120. Okay. One confusion might be, for the first part, it's 45. Having chosen 2, right, to form a line segment, I can pick any one of the remaining 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 more points. I can pick any one more in one of the 8 ways and form a triangle, right? So it might think 45 into 8, which is 360. Ananya, can you tell me what's wrong in this approach? Should I describe this approach again once more?
Yeah, so can you describe it again?
Okay, so I'm telling upfront is wrong, but I want you to find the flaw in it. Okay, use the part A, pick 2 points and draw a line segment. That we agree is 45 ways. Having done that, pick one of the remaining 8 points and form a triangle. So it's 45 into 8, which is 360.
So there will be repetitions.
How so? How so?
If you pick this blue line for suppose,
Yeah.
And you pick this point which you've marked, then you pick AC and then you pick B point.
Exactly. Yeah. In another situation, AC might have been my line of the 45 lines, and then B might have been the third point, right? So it's double counting, therefore it's 360 by 3, which is 120. Agreed? Right? Cool. What about, okay, I'll frame another part C. So part C is, there are 1, 2, 3, 4, 5, 6 points, 6 in a straight line. Okay, 6 in a straight line, and then there are 4 more points which are random here. Let's say here and here. Okay, so these 4 blue points that I've marked are not collinear with any of the pink points. Okay, so there are 6 points which are in a straight line. There are 4 points which are not collinear with any of these pink points, right? Which means I cannot draw a line connecting this blue line. So I cannot draw a line connecting this blue line and this blue line. It does not pass through this pink point. For example, I've illustrated where the 2 blue lines, the line they pass through does not go through the pink dot. All of you clear the setup right now? Now my question is, how many triangles can be drawn in this case? Using the vertices must be on the pink or blue points. How many triangles can be drawn? If the question is not clear, please ask right away.
Could I answer?
Okay, all right. Call out your answer.
Would
I'll
it
still
actually
give time for
four-
others. Yeah,
4 choose 2 into 6.
4 choose
I
2
don't
into
see any
6.
repetition here.
So which is 6 into 6, which is 36, you're saying.
Yeah.
Okay, all right. Let's see.
So I got 100.
You got 100. Okay, all right. Okay, anyone else with matching with 36 or 100 or a third answer? Sharma, anything? Shall we discuss, guys, or someone wants me to hold for another 30 seconds? Okay,
So just 2
okay, 20 seconds. Yeah.
Yeah, so even I'm getting 100.
You're getting 100. Okay, all right. Let's discuss. So how can we combine? The options are 3 pink points. There's no triangle at all possible, right? I cannot connect 3 pink points because they're all in a straight line. 2 pink and 1 blue. 2 blue and 1 pink, right? Or 3 blue. All of these cases need to be considered. With 3 blue, it's 4 choose 3. There are four ways in which I can select 3 from the 4 blue. 2 blue and 1 pink. I can pick 4 choose 2 ways of selecting 2 blue, and then one of the 6 pink points. Anahat, you were too fast to call out this wrong answer.
No,
That's what
but,
you did.
Didn't you say that it has to be on both pink and blue?
No, I said using all of these points, how many triangles can be drawn?
No, so you're saying assuming that the sides are all on pink and blue. Both.
Yeah, of pink or blue, which is how it'll turn out to be, right? 3
Oh,
blues.
I thought you meant that it has to be on both. You can't just have it on only the blue section.
But even then, it's 2 pink and 1 blue is also possible, right? So 2 pink, it could be 6 choose 2 into one of the 4 blues. So
but
that
you can't have 2 pinks, right? Because they're
why?
all,
Why?
they're all in a straight line, right?
True,
So
true, but I can pick this point, and this point and form a triangle, right? Agreed.
because even after I called it, I thought about it. I just couldn't find anything else because I thought it has to be.
No, but you agree this is a fair triangle, the last one I've drawn, right? So 2 pinks can be one of the line segments. 3 pinks cannot be, because that's why I said they're all in a straight line.
Right.
Okay, makes sense. So 6 to okay, maybe there was a confusion of pink and blue or whatever, but at the very least, I can agree if you did not count this one, the 3 blues, but pink and blue, that combination should have got this and this, right? So 6 choose 2 into 4, which is 60, right? 15 into 4, which is 60. So the answer is indeed 100. Yeah, well done, Ananya and Vihan. Also, Vihan, or was it Kunsh? Who was it? Vihan and Kunsh's voice come out, at least to my ears, the same way. I always get confused who answered. Who was this time?
Was me, sir.
Oh, okay, Vihan. Okay, all right, cool. Okay, 100 makes sense. Sharma, you're okay on this? Okay. Question 14. Eight people enter a room, sit randomly in 8 chairs. How many ways? We have done many of these kinds before. I mean, not many, some at least. How many ways can 3 sisters sit together in the row? Okay. Ananya, did you get an answer on this one?
So I took out the probability by mistake.
Oh, you found out the probability. Okay, all you have to do is remove the denominator and call out the numerator. You can tell it in factorials, it's fine.
So 6 into 3 factorial into 5 factorial.
6 into 3 factorial into 5 factorial. That's what you have. 6 into 3 factorial into 5. 3 factorial itself is another 6. I want to make sure it's 6 into 3 factorial into 5 factorial is what you called out. Okay,
Yes.
all right. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. Now these 3 have to be put on a box. Very similar, Sharma, very similar to what we did earlier, right? So I'm going to put C, R, and J in a cage, in a box. And now I'll say I'll need only 6 seats, right? There are 5 other people. Let's say the 5 other people are A, B, X, Y, and Z, right? Other than C, R, and J. right? So these are the 8 friends. So of which there are 3 sisters. So I'm putting the 3 sisters in a box. So with the 5 other friends, 1, 2, 3, 4, 5, and this box, I need only 6 seats technically. So that's 6 factorial ways of arranging them. All right. And then open the box, arrange C, R, and J in 3 factorial ways. So that's 6 factorial into 3 factorial, which matches with what you have. So 6 into 5 factorial, Ananya, is your 6 factorial. But can you explain how you called out 6 into 3 factorial into 5 factorial? What was your logic there?
So I took 8 seats. If C sits first, so there are 6 seats in which C can sit.
Okay. Understood. Okay. So what she's saying is, for the box of 3, right? I can start from here or here or here, like that, right? Can keep shifting the starting of the box position can be either in position 1, position 3, position 4, position 5, all the way to position 6, right? Okay. So there are 6 ways at which the starting position for C, R, and J can be. Having done that, the remaining people can sit in 5 factorial ways. And then within the box, they can arrange themselves in 3 factorial ways. Sharma, you're comfortable with both approaches, and it's good to see again that 2 approaches give the same answer. 6 into 5 factorial was the same 6 factorial. Yeah, all of you okay on this one? Okay, I'm going to give a few variants of this question. Okay, first variant. Okay, so first variant is actually, it's not even variant. Okay, I was just going to ask, how many ways can which C, R, and J are not all together? Okay, so I'll just say this is A part. So B part, not all of C, R, J are together. Okay, so Sharma, can you explain what this means? You don't have to call out the answer or anything. What does this sentence mean to you? Not all of C, R, and J are together means what?
Can 2 of them be together or can none of them?
Exactly. You answered that rhetorically. 2 of them can be together, but the third one cannot, right? But all 3 also can be separated. That's fine. But they should not be in a cluster of 3. Okay. So this is B part. And C part, okay, I think so. No 2 of C, R, J can be together. Okay. So this is more restrictive. This is saying even 2 of them cannot be together. Okay. Can we solve B as well as C? I'll give 1 minute. We'll discuss both answers together. Okay. Stop calling out answers on this one. Okay. I'll ask who will call out. I mean, after 1 minute, yeah, I'll open it up. But until then, please hold your horses. Okay. All right. Sharma, can you call out the answer for B part?
I'm not sure for B, but for C, I got 56.
Okay. For C, you got 56. Okay. In fact, B would have been easier, no? B would be the total minus the answer for part A. Right? Because you don't want them all to sit together. You already found, so the total is 8 factorial. And the answer to the previous question, how much was it, Ananya? 6 factorial into 3 factorial, if I recall. And that's it. Does it make sense, Sharma? For the B part, it's the total minus what the A part was asking. Correct? Do you agree? You're convinced? Okay. Yeah, which of course can be simplified. has 6 factorial times. This is 7 into 8. 8 factorial has 7 and 8. And then this has 3 factorial, which is 6. So it's 6 factorial times 50. Okay. Now, for the C part, without doing too much, I still think 56 is too small a number. Maybe, may not be. Let's see. Anyone else get 56 or some other answer? Vihan, what did you get for part C?
So even I got 56.
Oh, is it 56? Okay,
But
maybe.
I think I've made an error somewhere. but-
Okay. Anahat, what about you for part C? I could not hear you, Anahat, if you're mumbling
I'm
something.
finishing it off. I haven't finished.
Okay, all right, all right. What about you, Ananya Tantia?
So I have not done it.
Okay, I'll give 30 seconds more, all of you guys. It could be very well 56. I just thought it's too small a number, 56. Just imagine the situation, okay? So always go through, visualize what's happening. These people are there, they've arrived, you want to make them sit. What would you do to make sure that they're not together? What would you do typically? Okay, Anahat, your video is off. Any answer?
Just by accident. 1 second. I'm putting it into the calculator.
Again, you're mumbling something. I cannot hear you. I cannot comprehend you fully.
4320.
4320. Okay, at least that seems like a fairly big number. Okay, 4320. Okay, let's discuss, guys. Okay, all right. No two of C, R, and J can be together. Okay, so 1, 2. Okay, actually, before I do that, Sharma, can you justify what you did to arrive at 56?
I'm not sure if it's right, but 8 choose 3 because
Okay. 8 choose 3 is what? What is your 8 choose 3? From the 8 seats, you're picking 3 seats. Correct? Okay. What are you going to do with these 3 seats?
they'll, but I'm not sure how you would separate,
Huh.
like what you would do to.
Agreed. Yes, agreed. But 8 choose 3 will not help you because 8 choose 3 is you're picking 3 seats for C, R, and J, right? So what if that 8 choose 3, one of those 8 choose 3 could give you this seat, and this seat? That's no good for you. If your intention is to allocate them to C, R, and J, one of those 8 choose 3 will be allocating seat number 2, 3, and 5, which is not good for you because C and R, or 2 of them will be together, right? Right? So, okay. So instead, what would you do realistically? You'll call the remaining 5 people and make them sit first. What are the remaining people I called? A, B, X, Y, and Z, right? You'll first make them sit. Let's say B sits here, let's say A sits here, X sits here, Y sits here, Z sits here, something, right? They can sit themselves in 5 factorial base. Now you call the 3 fighting sisters C, R, and J and say, girls, insert yourself somewhere in these 6 spots. So pick 6 spots, first of all. Sorry, pick 3 spots from the 6 available spots, including the far left and far right, and arrange yourself in 3 factorial base. So C, R, and J will first say, we are picking this spot, and this spot, let's say. Right? And then they can decide to arrange themselves, or maybe I'll just, okay, it doesn't have to be always one apart, right? So like this spot and this spot and this spot, let's say, right? So having done that, they'll say R will sit here, C will sit here, J will sit here. That's one of the 6 ways, right? So first they select which 3 of the 6 spots, and then they arrange themselves in 3 factorial base. Does this make sense? Anna, this is what you did to arrive at your 4320.
I did something else, and also I think 4320 is wrong. It should be double of that. So
Okay.
basically, what I did was first said that there's two seats, and I split 2 and 5 seats differently, and I put one buffer in the middle. And then I said that I have two ways of choosing who goes in the first 2 seats.
Mhm.
And then oh no, so um, I realized I just calculated how many ways that there's only 2 sitting together. I forgot to subtract from that.
Okay. All right. Cool. Let's
My
see
bad.
what this. Okay. Yeah. But as long as you understood your mistake, that's good. Okay. So let's see what this simplifies to, just so that. Okay. 5 factorial is 120. 6 choose 3 is 6 into 5 into 4 by 3 factorial. And I'm multiplying this by a 3 factorial. So it's literally 6 into 5 into 4. So 6 into 5 into 4 is 120 again. So it's 120 into 120, which is 14400. Number of ways in which they can sit such that no 2 of C, R, and G are together. But that's all numerical computation. Anyone can do it. Of course, it's important to not make mistakes in that also. But conceptually, it's more important. Sharma, you're with me conceptually how to approach it? All of you good? Okay.
Yes, I just realized I just forgot to subtract from the total at the end. Other than that,
Understood. Okay. So that was question 14. Question 15. Okay, a game is played in which the wheel is spun. Okay. Whoever was able to do the homework on this one. Any Ananya, any answer on this one?
So I didn't understand this.
Okay. Anahat, what about you? You did the homework as well, right? Or you did
I
not?
could not understand what the question meant.
Okay. So okay, let's all take a 30 seconds to read this question again, guys. So some people have not even read it. So 30 seconds to understand the question, please. I'll explain. Okay, all of you read the question? Sharma, you read the question? Does the question make sense to you? In layman's term, can you explain with an example or something like that? Sharma.
I don't understand what you're asking.
Okay, good. Okay, fine. So it's the same spin, what is this called? Wheel. Same wheel that the player and the operator are both going to use, right? So let's say this is a casino, right? So this is the operator. The operator is sitting in the casino. Okay. And then this player comes to play the game, right? So player comes, so this is the booth where he's having this spin, right? So the spin is there, right? Now, both of them are using the same wheel. So the probability of them getting a particular number will be same. So let's find out the probability. So for it to be 1, what is the probability? For it to be 1, the probability is there are 4 ones of the 8 spots. For it to be 2, it's 3 out of 8. For it to be 4, it's 1 out of 8. Do we agree? Do we agree on these probabilities? Now, what's happening? The player, forget about game is fair and all that, right? Player, let's find out the probability for the player to win this game, right? So for the player to win the game, he must score higher than the operator, strictly higher, cannot even be equal, right? So the possibilities are the player scores 4 and this guy scores 1, or player scores 4 and this guy scores 2, the operator, or the player scores 2 and the operator goes 1. These are the only 3 possibilities, right? If it's equal, then the player does not win, right? For him to win, he must strictly greater than get this. So what is the probability for this one? So it's, okay, we just have to multiply, right? He must get 4 with a probability 1 by 8, and he must get a 1, the operator must get a 1 with a probability 4 by 8. Here it'll be 1 by 8 times 3 by 8. Here it'll be 3 by 8 times 4 by 8, right? So what is the sum of all these probabilities? So everything by 64, let's say, right? So it's 4 plus 3 plus 12 upon 64. So do we agree that for the player to win, the probability is 19 by 64? Do we agree on this one? All of you agree? Ananya, you agree with this? Probability of the player to win is 19 by 64. Tantia. Yeah, Sharma as well. Sharma, do you agree on the probability for the player to win is 19/64? Yes, good. Okay, Vihan, you're okay? Okay. Now, what is the question asking? This is probability, but what happens in reality? This guy goes to play the game, right? Obviously, if he's going to approach this booth, he has to pay some money to play this game and have some fun. For that, there is a cost, right? So he ends up losing K dollars for him to play this game. So he's short by K. He's lost K dollars of his money to play this game. Why did he play this game? Because there is some hope that he'll win, right? With a probability 19/64, he will win. And with the 19/64, how much will he win? He will win $8. So after the game, his expected outcome or expected profit is minus K because he already lost K in investing in playing the game. And then with 19/64, he has a chance of winning $8, right? So for example, let's say he pays $10 to play the game. And then let's say the game prize money is $1,000. Then he'll be very anxious to play this game. He'll be very eager to play this game because with 19/64 probability, or I'll make a number which is divisible by 64, right? So his win, so A is $1,280 if he wins, and the game costs only $10 for him to play. Then he'll be very glad to play because his expected win is 1,280 into this. So he'll expect to come out with $370 in his pocket, right? But obviously the operator is not a stupid guy, right? He'll run out of the business if he runs a game like this. He'll say, no, I cannot offer this much. But let's say it's only 128 instead of 1,280. Okay. Then what? Then the player's expected win is still minus 10 plus 38, which is 28. The player will still be eager to play this game. Okay. But then suppose this is only, let's say, $32. Okay. Then the expected win for the player is minus 10 plus 9.5, which is minus 0.5. Now the operator will say, Ajay, please play the game. But the player will say, no, on an average, I'll lose $0.5 if I play this game. I don't want to play this game. It's unbiased. It's biased towards you, right? If I play, which means if he plays 1,000,000 times, on an average, he'll end up losing $0.50 on an average. There will be occasional games where he'll win, but probability is all about average, right? On an average, it's a game which is advantageous to the operator. Now the question is asking, what is the ideal A? We agreed it's not 1,280. We agreed it's not 64. We agreed it's not 32. What is the ideal A and K connection, which will make it a fair game? Which means we are asking, when will the expression minus K plus the probability times A, his winning, will become 0. And that's the relation that ties A and K. So 19A by 64 equal to K, or whatever. You can just say this, right? If 64K matches with 19A, then it's a fair game, right? Both will be neutral in playing the game, right? On an average, neither stands to gain in this game. Is this clear, guys? Right? But typically, operator will be running, as operator is running a business, right? You'll always have a model where it's slightly higher. So the 32 is a good example, right? The player still knows that his expected gain is minus 0.5, right? Which means he's expected to lose $0.50, but still $0.50 is a small amount. It's a good enough bait. He'll go and have some fun, right? There's a fun part of it as well, right? There's a cost for that. He'll be okay to take a chance and have a good time, right? For that, he can think, I'm okay to take a loss of $0.50 to have some fun. And the operator will be happy to run it. He's running a business. On an average, with each game, he's gaining $0.50, right? And there'll be thousands of people coming and playing at the counter. He'll make some good money. So that's how it is in reality, right? Does it make sense, guys? All of you. Okay, cool. Okay, that was the last question in this paper. Now let's move on to question set 6. Okay. Okay. Kunsh, I'll start off with you because you are the one who said, I thought only question 6 we have to do.
Sure,
Kunsh, was that you, right, Kunsh? Okay,
Yeah.
yeah. First one, yeah.
So I got 1296.
1296. Okay.
Yeah.
Okay. Sharma, you said you did this as well, right? What did you get?
729.
729. Okay. All right. Kunsh, can you explain how you got 1296 on this one?
Wait, sir. I just realized my mistake, sir.
Okay.
Wait, can you give me 2 minutes, sir?
Okay, no, I'll discuss because these are all homework problems, right? I want to discuss. Anyone else got? So he's agreeing his answer is wrong. Anyone else matches 729? Ananya, you also got 729. Okay, Sharma, can you call out your 729? How did you get 729? So this is the sorry. So this Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, go ahead, Sharma. Explain your 729.
So I didn't use, I just used kind of logic. But
Yeah,
Oh.
I'm always encouraging of logic. Don't think there's too much math. Most of these questions are just logical. Bolo.
So there are 4 desserts,
Yeah.
and since there must be cake on Friday, there's only one for Friday. Yeah, cake on Friday, and there cannot be 2 desserts served in a row. So for Saturday, you have only 3 options.
Okay.
It'll be pie, ice cream, or pudding. Then Thursday also you'll have only 3 options.
Yeah.
But now since on Thursday you will choose one of the desserts, that means on Wednesday you'll have 3 options as well.
Exactly. And then work it backwards. Exactly. Yes. Okay. And then he's trying to trick you by saying he must make a menu starting with Sunday. That does not matter. He'll make the menu with this constraint as she called out rightly, right? Friday is where the constraint is. It has to be cake. And then he'll work forward and work backward. Forward is just only one day, Saturday. Work backward, he'll go travel all the way back to Sunday. And that's it. When he publishes the menu, no one knows which day he filled first. And he'll publish the menu Sunday to Saturday. Because one of the wrong answers people will call out is Sunday I'm starting off. I don't have any constraint. So in fact, I'm going to ask you this. So what's wrong in this logic? Sunday I am starting, no constraint. Monday can be anything other than that, anything other than that, anything other than that, anything other than that. Friday, yes, I have the constraint 1. So what is wrong in this, guys? Kunsh, can you tell me what's wrong in this one? In the second approach? That also seems fair, right?
Because on Saturday you've already chose something. On Sunday it can't be the same thing. So there's no 4 options, only 3.
Why? No, my week only runs from Sunday to Saturday. That's it, right? I'm running the shop only for a week. I'm not talking about the next week at all.
Thursday,
But
there's-
it's because of last week.
No, that's what I'm saying. There's no last week. I'm only concerned about this week. That's it, right? Prepares the dessert for every day of a week, right? So I'm concerned. I'm running the shop only for a week. Just imagine that. There's no previous Saturday. There's no next Sunday I have to worry about. So with that, yeah, Anahat, you're saying something?
Would there be like you have to do 2 on Thursday because like you have to adjust for Wednesday and Friday and then adjust everything else.
Okay, so basically you're saying the answer should be 4 into 3 into 3 into 3 into 2 into 1 into 3. That's what you're saying?
No, because that's not the same. But I'm just saying you'll have to adjust for other things as well. So let's say you take this logic on Thursday, it won't be into 3 because you can't have the same thing as Wednesday or Friday. So it'll be into 2 there, and then on Wednesday also you'll have to. Then let me think about the whole thing all the way down. But basically, there'll be some like double counting there.
Exactly. Right. So if, right, as he rightly said, right? So if you're traveling from Sunday and let's say the 3 options here, if those 3 options included a cake, then it'll become a 2, right? But if the 3 options did not, let's say the cake was here, he was anyway not going to go for a cake here. So he'll still be 3. Right? So in some situations, it could be 3. In some situations, it could be 2. You'll have to back work for each of those cases and it'll be a big mess. You can neither put a 3 nor put a 2. Right? And therefore, this approach, well, you can take it, but then you have to back work at every step, which is meaningless, right? You'll be there all day. You'll be there all week, actually, doing this problem. Right? And therefore, it's better off to start with where the constraint is, not just this problem. Every problem in permutation, combination, or probability, start with where the constraints are divisible by 5, starting digit cannot be 0, this, that. Wherever there are constraints, fill those spots first. Then you can be bindas about filling the rest. Okay. The only main trick here is he started by saying starting with Sunday, right? Had he said prepare this thing starting with Friday, then all of you would have got it right. Because he started with Sunday, it's tempting to say Sunday I'm free, and then I run into this problem, right? Come Thursday, right? Depending on the number of options, again, that depends on Wednesday. If Wednesday had a cake, then Thursday, perfect. I'll have one of the other three, and it won't be cake anyway, and Friday will be a cake. But if, let's say, Wednesday was an ice cream, then Thursday can neither be ice cream nor be cake, because it will affect either Wednesday neighbor or Friday neighbor. Then it will be 2. But how do you deal with 2 separate cases? Again, we have to back work every single point. So as long as we appreciate it's confusing and too much work, we are good, right? It won't work. Okay, cool. Let's go to the next one. Okay, where am I right now? Why is this not going up? Okay. Okay, question 2. How many digits? How many even integers are there between? Why is it pasting here? I want to paste it up there. Okay. How many even integers are between 200 and 700, whose digits are all different and come from the set 1, 2, 5, 7, 8, 9? Ananya, what did you get on this one?
So 24.
24. Okay. Anyone else with 24? Kunsh, what did you get?
I also got 24. Sir.
Okay. Vihan,
Same.
same. Okay. You're just playing it safe, or you actually got 24?
No, actually.
Okay. Vihan, why don't you explain your 24?
Yeah, so basically, what you do is, because it's asking how many integers you got between 200 and 700,
How many
but
even
it also
integers?
has even integers.
Yeah.
But it also has to be from the set 1, 2, 5, 7, 8, 9.
Yeah. Yeah.
So
Yeah. Go ahead. Vihan is frozen. Is it for me or for everyone? He has frozen. Okay. Kunsh, why don't you take over? You got 24, you said, right? Kunsh.
Sure. Yeah, so we know it must end with the 2 and 8. So
Yeah.
right. And for the first one, it can be 2, 5, 7. It can only be 2 or 5, sorry.
Okay. 2 or 5. Okay.
Right.
Mhm.
And so in between, it can. Sorry, sir. Yeah. Oh, wait, my approach is wrong. So I have to create 2 different scenarios. One for 8 and
Exactly. Yeah. 2 is
Right,
appearing
yeah.
here as well as here, right? Therefore, you have to have 2
Right,
different
right.
cases. So if it ends in 2, okay, so it ends in 2 versus ends in 8. If it ends in 2, so obviously I've used up 2 one way, and then the last digit can only be 5,
5.
right? So there's only one way, and this beachwala digit can be any one of the remaining 4. So there are 4 ways for
Right.
this. If it ends in 8, the last digit is 1. This digit can either be 2 or a 5. There are 2 ways, and the beachwala can be any one of the 4. Therefore, it's 4 plus 8, which is 12. Vihan, you were frozen in between, but 24 was wrong, as we discussed. Ananya, did you find your mistake? You said 24, right? Or what was your mistake, Ananya?
So I did
So
2 into 6 into 2. I took there are 2 options for the last digit, and then there are 3 factorial ways of arranging it. I did.
What arranging? If you already used up the last digit as that, there's no arranging after that, no?
Yeah.
Okay. Sorry, was there a question? Someone else had a question? Okay. All right. Same question. Let me just modify. I'll remove all digits are different wala constraint, whose digits come from the set, which means they can repeat. Can we do the alternative question now? Can we do this one, guys? Whose digits come from the set 1, 2, 5, 7, 8. So which means I'll be okay with a number like 272. I'll accept this. Okay, Kunsh, you want to go? You have an answer?
Won't it just be 24?
Okay, maybe it is 24. Okay, all right. Okay. Anyone else agree or disagree quickly? 10 seconds. Sharma, you agree?
20.
Okay, yeah. So the last digit is 2 or 8. The first digit is 2 or 5. It can have a repetition, therefore we don't have to worry. So 2 options here, 2 options here, all the 6 options here. Therefore, it's 24 indeed. Okay, well done. Okay, that is question 2. Question 3. The round robin tournament with 6 teams. Each team plays 1 game against each other. Okay, so Vihan, how many games will there be in total? Vihan, are you there, or I cannot see you? Your video is on, but probably you're nearby somewhere. Okay. Ananya, how many games will be there in total?
So 15.
15 games. So see, each pair plays a game. Therefore, 6 choose 2, which is 15 games will be there. Okay, Sharma, what is the maximum number of teams that could be tied with the most wins? Can it be 6? Can all 6 tie with 1?
I don't think all 6 can't tie.
Why not?
Then get further than that, because then the chance of winning would be like 2.5 or something.
Not chance, but yeah, the points, right? Yeah, correct. 15 by 6 is 2.5, not an integer. Each game can only get either 1 point or 0 points. So for everyone to get 2.5 points is not possible. Okay, so 6 is ruled out. Is 5 possible? Can 5 of them, just because 15 by 5 is an integer, that's only a necessary condition. For it to be an integer, it's a necessary condition, right? So 5 of them getting 3 points. So 3, 3, 3, 3, 3. One guy getting 0, right? Of course, if you get 2, 2, 2, 2, 2, then this guy will get 5 points. So this guy will be the winner, right? So we don't want this. But the first situation, 3, 3, 3, 3, 3, 0, is that possible? Can we structure an outcome such that the end result looks like this? Sharma, what do you think? It's possible, you think? Sharma, you can unmute. Yeah.
Wouldn't it just be 5 then?
Yeah, but all I'm saying is, just because this answer is an integer, it doesn't, you have to actually come up with an outcome where it is possible, right? So what I'm saying is, just because this is a necessary condition, not a sufficient condition. It's an integer, that's a first condition. But just because an integer, are you able to actually come up with an outcome where A gets 3 points, B gets 3 points, C gets 3 points, and all that, and F gets 0 points? Can you give me an example outcome which will guarantee me this? For example, 10, A defeats C and D, whereas A loses to E and F, something like that. Give me an example where it will work out. Can you, Sharma? Anyone else thinks 5 is possible? Ananya, you think 5 is possible or not possible?
Yes, sir. It's
5 is possible. Can you give me an example, Ananya?
Yes, sir. So A wins when it plays against C, F, and E.
A wins C, F, and B. Okay, A defeats C, F, and D. Okay, all right.
B wins when it plays against A, C, and E.
Okay.
C wins when it plays against D, E, and F.
Okay, so B wins against A, C, and E. Okay, what is the pattern you're using? I'm not seeing the pattern. You have a particular pattern in mind, or?
No, sir.
Okay, all right. Continue, please. Okay. D wins.
B, A, and E.
B, A, and E. Okay, all right.
And F wins against.
No, what about E? You didn't cover E.
No, sir, I took F because I used up E's.
Okay, so E is a loser who loses to everyone.
Yes.
According to you. Okay, fine. F wins against.
So remaining, I didn't do.
Okay, remain. No, but remaining, but you should be careful. There's no contention here, right? Yes.
Okay.
So, okay. So basically, she is putting A, B as, she's putting E as the worst guy who lose against everyone. Doesn't matter which one you put. Okay. Okay. She's following some random structure, I would say. An easier way would be, let's say you arrange the 5 people. Okay, I'm going to put F as the worst guy. right? As the worst guy who's going to lose against everyone, right? Everyone will trash F. In addition, everyone will win exactly 2 and lose exactly 2. So going clockwise, we can say A will win B and A will win D, right? The arrow mark says they'll conquer this guy, right? And B will win D and B will win E, right? Similarly, D will win E and D will win C. And E will win C and E will win A, right? So E will, okay, this E will win C and E will win A. And then when it comes to C, he will win A, C will win A, and C will win B. So that way, you have a symmetric arrangement. Or in other words, if you look from A's perspective, right side may do, you'll win. Left side may do, you'll lose. And there's no violation this way, right? So it's symmetric. So does it make sense, Ananya, this arrangement of representing? That way, there's no clashes. Here, if you are randomly arranging, then you have to worry, what if A came here and F here, and let's say, in this case, F, right? Let's say, and F came here and A came on the right side, then there's a clash, right? So you'll have to worry that there's no clash between these two, right? There's no contention between these two, let's say, right? But if you write it like this, it's symmetry and therefore it's possible. Okay, we are up on time. So there are 3 more questions, I think, to discuss, but we'll continue. But pretty much we are done with, Sharma, are you caught up with the videos from earlier, or slowly try to catch up the ones that you missed earlier? Okay, all right. So we'll do other topical questions, homework. Mostly it's going to be algebra for next week. I will discuss. Just to be clear, we'll finish the rest of the remaining homework 6 discussion, and then we'll move on to homework 7 wala discussion, which I'll send it by tonight. Okay, chalo, bye. See you guys.